In this Asteroid Day exclusive, we introduce you to people who are leading the efforts to investigate asteroids in our solar system, including their potential for great destruction of all we find precious on Earth. The series will take us from what we know today to new discoveries in science and technology that can safeguard generations to come. Asteroids are leftover matter from the formation of planets. Most of them orbit in a belt between Jupiter and Mars, the asteroid belt. But some of them have entered the inner solar system and crossed Earth's orbit. Those are the ones that need attention. Asteroids tend to be dark and move against a black sky. If a large one collides with Earth, the destruction would be greater than anything we've ever seen. June 30th is Asteroid Day, and we hold it on the anniversary of the largest asteroid impact yet witnessed. Part of the Siberian forest, spanning an area nearly 1,000 square miles, was flattened, incinerated, destroyed by a relatively small asteroid. Today, we have the technology and expertise to find. In this Asteroid Day exclusive, we introduce you to people who are leading the efforts to investigate asteroids in our solar system, including their potential for great destruction of all we find precious on Earth.
As a human being, flying in space around this incredible planet, you fall in love with it, and you realize, with a very thin iridescent blue band, which is the atmosphere that goes all the way around the planet, that's all that keeps us alive.
The threat is low, but the result can be extremely high. And we are now, for the first time in our history, at a level of technological capability to maybe detect and do something about the threat from asteroids. It's part of the legacy of this big brain and the level of quality of life that we built all around the world.
As far as we can tell, the ancient dinosaurs did not have a space program, and it cost them. They all went extinct. We don't want to go that way. An asteroid or a comet is a real and important threat.
Asteroids are just rocks orbiting the sun. Every single known asteroid in the solar system, which is not all of them, but every single known asteroid accurately displayed.
We know basically more than 90% of the objects which are larger than 1 kilometer in size. And this is the threshold for global effect on Earth. Problem is now we only know 15-20% of objects which are larger than a few hundred meters in size. And these bodies, if they impact Earth, they can make regional damages, country or even a continent.
The thing is, there are an awful lot of smaller ones which could do a hell of a lot of damage. This class of asteroid are really not charted well enough. We came to the conclusion that we needed about 100 times more vigilance to find every one of these possible impactors.
Asteroid Day has this declaration that we would like to see the rate of asteroids discovery increase by a factor of 100. That's what I would like to see. I think discovering asteroids, that's the critical step. You can't deflect something that you haven't discovered. So in a way, it's like looking both ways before you cross the street. Finding the cars, seeing the cars doesn't keep them from hitting you, but you can take evasive action. In the case of looking both ways before you cross the street, if you see a car coming, you stop. If you see an asteroid coming, well, you deflect the asteroid, but you have to see it. In a way, it's just common sense.
And the really good news is that if we look a few decades ahead, it should be possible not only to predict a possible impact, but also to do something to reduce its impact by deflecting the asteroid. What we need to have is a survey of the sky which is sensitive enough and complete enough to discover all the Earth-crossing bodies down to a size of, say, 50 meters.
One of the things about asteroids is it's a threat that we can really quantify because we can count them.
Most of the asteroid searches, interestingly, are done in the northern hemisphere, not in the southern hemisphere. and we need to have more searches in the southern hemisphere.
There's interest in South Africa of becoming a place where near-Earth asteroids could be detected, and geographically we would be a very good complement to other detection sites such as the southwestern US and Hawaii.
Actually, most of them now are detected by the Pan-STAR telescopes and the Catalina Sky Survey in Arizona, which dominate the discoveries.
Catalina, we focus on the discovery and follow-up of near-Earth asteroids, and it's a really interesting place to be because that's where the whole process starts. You can't characterize or understand the impact risk of an object that you haven't found.
We need to have one or more space-based infrared telescopes. And today, while there are a couple of them that have been proposed, none of them has been funded yet.
With a space-based telescope, you can see in a lot more directions. You don't have a daytime sky to contend with. And two, with an infrared telescope, asteroids are much brighter than they are in reflected visible light.
There are actually a lot of things out there in space which could affect us very deeply and could wipe us out. Most of them are really not predictable and not avoidable, like a gamma ray burst. We don't understand those well enough to know yet whether we could fall a prey to something like that close by. A supernova certainly could give us severe problems, but you cannot predict any of that stuff. We think that strike by something very local, which is in our own little patch, our own little solar system, it could wipe us out or it could cause us severe damage, and probably with our present state of knowledge, it is detectable and it is avoidable. So let's think about the serenity prayer for a moment. You know, you do these things which you can do. The things you can't do, you have to put off for another day. We can do this. We can look at this threat and we can probably minimize it and maybe avoid it.
In this Asteroid Day exclusive, we introduce you to people who are leading the efforts to investigate asteroids in our solar system, including their potential for great destruction of all we find precious on Earth.
All sorts of stuff, isn't there, are going around in space. I mean, whether it's little bits of debris or flecks of paint, or are we talking about actual natural mini asteroids, let's say, all sorts of things. When I got to the space station, I was shown where I was going to be sleeping, and I was given one of the little bedroom areas, and there was a window, and there was a little pit in the window, and I was told that there was a little meteor must have hit that. It only happened a couple of days ago, but it'll be fine for you.
We're currently looking at how we could respond to a whole range of space threats, whether they be space weather, whether they be space debris, man-made objects coming back to Earth, or even asteroids.
The more we learn about all of these objects, the more we can be prepared for possible impact, for preventing an impact that would be dangerous to us.
It is time now for testing realistic mitigation techniques in space in an international cooperation frame.
I suspect in the future we would have a range of tools in our armoury. So one would be the gravity tractor, one would be a kinetic impactor. The gravitational tractor is a very elegant solution to this particular problem. Effectively it uses the mutual attraction of a space probe and the asteroid to modify its orbit.
But another exciting possibility is an international project involving the United States and the European Space Agency called ADA.
An experiment which will enable for the first time a human-made object to rendezvous with a binary asteroid. Why do we want to rendezvous with an asteroid? Well, we need to know what would happen if one of these asteroids hits the Earth. We need also to try and avoid that happening. And this experiment is actually to try and see what happens if you hit an asteroid with an object.
Using a technique called the kinetic impactor, so this is the IDA mission. So when you want to interact with such a body in order to deflect it, it can be very tricky. Like a 200-meter object has a very low gravity. So basically when you are on the surface of a 200-meter object, you don't really stay. Because on Earth we stay because it's very massive. A 200-meter object is very, very small. And therefore, if you move, you can easily go away. And this is why you need first to discover them all, and also to be able to test your ability to deflect such kind of body.
If there's one thing I learned during my years as an astronaut, it is that the key to success lies in the testing beforehand, because You don't really know what's going to go wrong until you've done something for real.
In this Asteroid Day exclusive, we introduce you to people who are leading the efforts to investigate asteroids in our solar system, including their potential for great destruction of all we find precious on Earth.
If you want to deflect an asteroid, you have to push on it somehow. You have to push on it by hitting it with something, or by exploding a nuclear explosion next to it, or by gently nudging it. But all those methods depend on the structure of the asteroid, the strength of the asteroid, the density of the asteroid. We have to know all these things in order to properly give it that little nudge so that it drifts away from its trajectory and doesn't hit the Earth.
When a survey discovers an asteroid, we are basically trying to characterize the object from its orbital elements. So if you're doing something beyond the orbital elements, for example, if you want to find out how fast it's rotating, what it's made of, what are its surface properties, is it covered with regolith or is it bare rock? This is the next step beyond the orbit. Think of it like you're going in a forest and you're taking account of all the animals that are there. That is the first step, in the sense that you're trying to find out which animal is in the forest. So surveys are kind of our first eyes and ears in the forest. Characterization is trying to find out how the lions behave when they come out, when they eat, what they eat, when they sleep. So it's the next step beyond finding out what is out there.
Many asteroids contain organic material. We know asteroids made a lot of impact onto Earth, especially when it was born at the end phase of the Earth formation. They probably brought the water on Earth. We have good evidence for that. And what we want to see now is whether when they brought all this material on the Earth, maybe they also brought all the material that made life emerge on Earth. So maybe they, let's say, created life on Earth, and now they are able to finish it. So they have the pros and cons is balanced.
In this Asteroid Day exclusive, we introduce you to people who are leading the efforts to investigate asteroids in our solar system, including their potential for great destruction of all we find precious on Earth.
And the most likely thing to be hit by is something reasonably small. Chelyabinsk was about the size of this room. You double that or triple that, and you're talking about something that could wipe out a city. So we are talking now about dealing with risks that are different from a global catastrophe.
Well, the biggest threat, of course, is the big one. The asteroid which is big enough to kick up enough stuff into the atmosphere when it hits us to give us a long enough winter to exterminate life. And it doesn't have to be very big. Now, we think we know where all the big ones are, and we think we're safe, but I don't think it's absolutely certain.
If we had more robust methods for detection, and we were able to detect these smaller objects, then we would be able to warn, inform, and advise communities, populations worldwide of any incidents that would occur as a result of a Tunguska-sized impact event. And if we were able to do so, then we would significantly reduce the number of fatalities and the number of casualties.
We have to think about crisis management for something that's definitely going to hit the Earth. But if we had a couple decades on an object like Apophis, we could deflect it.
If an asteroid was found to be on a collision course with the Earth, and let's say we had a 20-year warning time. Well, I don't necessarily see that as warning time, it's preparation time. It takes about 5 years to design and build a mitigation mission in order to deflect the asteroid away from the Earth's orbit. If that were to fail, then again, we've got contingency planning arrangements that need to be made. The first information I would ask the scientists on the discovery of a 300-meter asteroid hurtling towards the Earth would be very much, what's it made of, if they know at that time? The speed that it's hurtling in at, the angle that it's hurtling in at. Because the angle and the speed, again, have impact effects, consequences on the ground, and particularly the risk corridor.
Which is a line all the way across the Earth where if an asteroid is going to hit the Earth, it will hit somewhere on that line.
But equally it tells us where it's not going to hit. So where areas of safety could be, and where areas of safety within those countries and those regions could be, so that you can choose